So a bunch of nerds in 1947 put together the first transistor over at Bell Laboratories. Let's see if we can do it some 50 years later in the Jeri Nerd Laboratory. This is a drawing of the first transistor. It was a wedge of plastic with a piece of foil wrapped around it with a thin slit cut in it, pressing against a slab of semiconductor mounted on a base. To the right you can see a schematic representation of a bipolar transistor that we still use today. See the resemblance? Before we can do the fun stuff like make transistors, we've got to get some of the semiconductor physics out of the way. In this project, we'll be using germanium for our semiconductor. In pure semiconductors, the electrical conductivity is very low due to the covalent bonds that tightly bind the electrons so they can't move from atom to atom. However, we can change the electrical properties by introducing impurities into the semiconductor, replacing some of the atoms. If we add an atom such as phosphorus, the conductivity will go up. This is due to free electrons that were not bound by covalent bonds. This is called N-type material. Another method is to choose an atom that does not complete all the covalent bonds and leaves vacancies, or holes. Current flows by electrons moving into holes, and the holes moving through the crystal lattice. This is called P-type. We're going to harvest our semiconductor from this germanium diode. It's called a 1N34 cat whisker diode. It has a cat whisker of tungsten that pushes against a germanium block. See the resemblance in the electrical symbol? The germanium is already doped N-type. Before we move on to transistors, let's look at the diode, because mechanisms are going to be similar. On one side we have P-type with excess of holes. On the other type we have N-type, and they're joined together. At the PN junction, holes and electrons diffuse towards each other and recombine, neutralizing each other. Since there's no charge carriers, this becomes a highly insulating piece of semiconductor. It's referred to as the depletion region. Current will not flow through a PN junction unless a forward bias condition is established. For this to occur, a positive potential is applied to the P-type and a negative potential to the N-type. Electrons are repelled from the N-type and holes are repelled from the P-type until the depletion region decreases and conduction can occur. The P region in the germanium diode is formed by the point contact and a special forming process that we'll discuss later. This is a representation of a PNP bipolar transistor. It has a highly doped emitter which emits holes, a lightly doped base which has an excess of electrons, and a lightly doped collector which collects the holes. The emitter-base junction is a forward bias diode in this diagram. When electrons go into the base, holes are attracted and diffuse into the base. Some are recombined in the base, and this is the base current. But the base is lightly doped, so there are not enough electrons to neutralize the holes, and they continue to diffuse over to the collector. A very small current between the emitter and base can switch a very large current between the emitter and collector. Okay, that was a lot. I hope you're all with me. Let's get to the point contact transistor. We're going to start with an N-type piece of germanium and 2 point contacts. This is a view under a microscope of the inside of a germanium diode. That's the cat whisker and the block of germanium. This is what we're going to try to get, the germanium. I found 2 ways. You can sand through and open a hole. This seems to work pretty well. This took me less than 5 minutes to get through with 400 grit sandpaper. And this is a technique for making a transistor that goes back to early hobbyists. They would crack open germanium diodes, use the original cat whisker, and use the germanium block as the base, and they probe around until they found a suitable collector that showed gain. I didn't have much luck with this, but this was before I learned about collector forming. However, I did have some success just busting the diode open and removing the germanium, leaving it attached to the lead. This is the view under a microscope of the germanium block itself. It's interesting that it's been etched so that it has little dimples. I've read that this is for retention of the cat whisker. Early patents state that phosphorus bronze points are critical in the collector formation. I found that this material is very common in connectors, so I went through my spare parts and I found some connectors that happen to have this. I bent the tabs out and then I sharpened them with a piece of sandpaper as best I could. This is a comparison of mine versus the cat whisker that came in the diode. Mine's at the bottom. I've tried sewing needles, I've tried gold-plated pogo pins, but the phosphor bronze is the only thing that seems to work for me. After your emitter and collector are in contact with the germanium as close as possible, you need to do the collector formation. You do this by discharging a capacitor through the base and the collector forward biased. There's no good information on what the voltage is and the size of the capacitor and resistor is supposed to be. I use 330 microfarad, 680 ohm resistor at 20 volts. This is my test fixture, 2 phosphorus bronze contacts at 45-degree angles. My base is the germanium diode in between, soldered down, and a rubber band holding the tension. I used an oscillator so I wouldn't have to look at an oscilloscope to know if I have transistor action. If I have gain, the oscillator will start. There's an awful lot of fiddling around you have to do to get the contacts in the right point. I also found you have to often reform your collector if you're moving the points around. Alright, here it comes. You're going to have to listen carefully. I'd like to dedicate this video to the late Jim Bird, one of my earliest electronic mentors, who sat me down and taught me how to use a bipolar transistor, a germanium one, I think. It was in a tin can. And to everyone that's out there mentoring kids,